Hi class. So today we are going to take a few notes on angles and different properties within angles and angle relationships. So what I would like you to do is follow along with this video and complete the 4.1, 4.5 vocabulary sheet. Feel free to stop this video at any point, pause it, rewind, make sure that you are able to get all of the necessary terms. So first thing we need to define is an angle. So an angle is a figure formed by two rays with a common endpoint. That common endpoint is called a vertex. Now, if I create an angle with these 3 points, let's say that I want my vertex to be at point B. So I'm going to have one ray going through point A and one ray going through point C. So with this angle, there are multiple ways to name this angle. This angle can be named, angle B, or it can be named using all 3 letters where your vertex is always the center letter. So for instance, it can be angle A, B, C. Lastly, it could also be angle C, B, A. So you can either name with just the vertex if there's only one angle that you're looking at, or if you are naming it with 3 points, the middle letter should be the vertex point. So now let's take a look at naming this figure here, all the angles in this figure. This figure has actually 3 angles within it. It has one angle here, this angle. It has another angle here, and then it has the larger angle. So, delete all that. So now let's go back and try and name these angles. So the first angle, the top angle there, I can name this angle W, X, Y. I can also name it Y, X, W. All right, let's look at the bottom angle. The bottom angle is angle Y, X, Z, or I can also name it, Z, X, Y. So I can just name it in reverse if I wanted to. Lastly, the big angle there is angle W, X, Z, or you can say angle Z, X, W. Think about this. Could I name this figure angle X? Hopefully you're saying no. We cannot just use angle X because there are, like I said, 3 distinct angles in this figure. You can only name with one letter, one vertex, if there's only one angle in the picture. Okay, so let's move on to some more angle properties. So this first angle that we're going to talk about is an acute angle. Whoops, sorry about that. First angle we're going to talk about is an acute angle. So properties of an acute angle. Basically, it needs to measure anywhere between 0 degrees and 90 degrees. Next, a right angle. A right angle has to equal exactly 90 degrees. An obtuse angle must measure between 90 and 180 degrees. So obtuse, it's a little bit larger. And then a straight angle, again, will equal exactly, this time, 180 degrees. So hopefully these 4 angles are not new. Hopefully you've heard about them quite a few times before. Now let's talk about some relationships. So we have what's called an angle bisector is one of your terms here. An angle bisector is basically a ray that divides an angle into 2 congruent angles. So as you can see in this picture, see these tick marks right there? Those red tick marks? Those tick marks are showing you that the ray YW is actually cutting that larger XYZ angle into two congruent pieces. Next, we're going to talk about adjacent angles. So adjacent angles are two angles that share a common vertex and side. So your vertex being down here and sharing this common side, that common ray, but they don't have any interior points that are the same. So angles 1 and angle 2 are adjacent angles. Again, feel free to stop this video or pause this video if you need to as we're going through these definitions. Next is complementary angles. Hopefully you've heard about this before. Complementary angles are two angles whose measures have the sum of 90 degrees. So if we added 58 plus 32, you're going to see that that actually equals 90 degrees. So therefore those two angles are complementary. Supplementary is two angles whose measures have the sum of 180. So again, if I did 75 plus 105, that's going to give me 180 degrees. So that means, oops, sorry, that's a 0. So that means that these two angles are supplementary. All right, two more. Next, we're going to talk about linear pairs. So linear pairs are two adjacent angles whose non-common sides are opposite rays. So two adjacent angles, so we said adjacent means they share a common vertex and side, but this time the side that they don't share, so this side and this side are going to be opposite rays. So opposite rays form 180 degrees. So linear pairs should always be angles that are touching each other, sharing a common side, and forming a straight line, hence the word linear. And a straight line is 180 degrees. And lastly, we have vertical angles. So vertical angles are two angles whose sides form two pairs of opposite rays. So you have your your two angles forming opposite rays. So there's your opposite rays going that way. We also have opposite rays going this way. And the vertical angles themselves are actually up and down and left and right. So angles 1 and 4 are vertical angles, and 2 and 3 are vertical angles. Now we're going to briefly talk about measuring angles with a protractor. This is something you're going to do more practice with tomorrow in class. However, I just want to go over a couple of things real quick now before we get into that tomorrow. So when you're measuring angles with a protractor, some things that you need to remember here is a protractor has a straight line. I can't write over top of this, but we have a straight line going along the edge here. And that straight line represents 0 degrees or 180 degrees. Notice how the inside numbers go in one direction and the outer numbers go in the opposite direction. So depending on where your starting ray is, that'll determine whether you use the inner numbers or the outer numbers. So let's do a couple practice problems. Here we have angle 1 here. So if I take my protractor, we want to always line our protractor up with the cross section right at your vertex and make sure that that line corresponding with 0 degrees here is lined up perfectly with one of your rays. At this point, At this point, we can now take our protractor and measure, if I continue to go up, where is my second ray going to intersect? And it's going to be at approximately 40 degrees for this one. Notice how we are using the inner numbers, because when we're measuring an angle, we always assume that we're starting at 0 degrees and increasing from there. Okay, next one. Over here, again, we're going to have to line everything up. Our cross section is right at our vertex, and then we are going to line up our 0 degrees with one of our rays. And then we are going to look for where our second ray intersects, which if we go up here, matches right at about 90 degrees. So this would be a 90-degree angle. So remember, what's the name for a 90-degree angle? It's a right angle. That's an angle symbol. All right. Next, if we are trying to measure this angle here, we are going to want to look at taking our protractor and actually turning it slightly. I want it to line up perfectly with one of the rays. I'm going to say, I'm going to use this ray here. Let me turn it a little bit more. And it needs to line up perfectly. So we have the cross section down here, and it lines up at 0 degrees. Now be careful. This time, my 0 degrees is on the outer set of numbers. So this time I'm going to follow the outer numbers. So if I follow it all the way around outside, it is approximately 122, let's say 122 degrees, which makes sense. If you think about this angle, if you think about this angle, it is an obtuse angle, so it should be a larger number, something in between something in between 90 and 180 degrees. Okay, last angle that we're going to measure here. We are going to look at this angle down here that has, there's my cross section, good, and again, my 0 degrees is on my left-hand side, which means that I'm going to start by looking at my my top numbers. So 0, I'm going to go all the way up until I reach my second ray, which is at approximately 71 degrees, which again makes sense because it is an acute angle. Okay, last thing we're going to do here is quickly measure or construct two angles, one with a measure of 42 degrees and one with a measure of 110 degrees. Now, it doesn't matter where your starting ray is. It can be facing the left or facing the right. It doesn't make a difference. So I'm going to do 1 and 1. So I'm going to do this one. I'm going to start facing, ray going out to the right. All right. So now we're going to grab our protractor, and I want to line it up perfectly here. And, oops, I don't know why that just jumped. Sorry about that. I'm going to line this up at my vertex and line up that ray, and I want to go to approximately 42 degrees, which is about somewhere right around there. I'm going to grab another ray, and with my other ray, I'm going to construct, there we go, something around that. Sorry, it's a little challenging to do on the computer. All right, and the last one we're going to do is 110 degrees. So again, I'm going to draw a ray. This time I'm going to have my ray facing in this direction, and we are going to grab our protractor, and if we line everything up, 110 degrees, remember we're starting at 0, so now I'm going to go all the way around, whoops, sorry about that, all the way around until 110 degrees. So 110 degrees is approximately right about there. So when I draw my ray, I'm going to go from my common vertex up to that 110 degrees. So this angle in here is an obtuse angle of 110 degrees, which makes sense. And this angle down here is an acute angle of 42 degrees. Okay, so hopefully you have kind of an idea of how to use a protractor. Tomorrow in class, like I said, you're going to do more practice with a protractor. You can finish the very few questions on the front and back of your vocab sheet before coming to class tomorrow. And then we will move on to angle addition postulate, which is always a fun concept as well. All right, enjoy.